video talks about what happens during carbon fixation. Now, as a review from last lesson, you have learned that carbon dioxide comes from air and it will combine with H atoms. These H atoms are now held by NADP, the carrier, from photochemical reactions. Carbon dioxide as well as H will combine to form glucose, which is the immediate product of photosynthesis. Now, this glucose, you have learned in lower forms, will also be turned into starch for storage, but this is not part of carbon fixation. Anyways, in order for this process to happen, energy is needed. And this energy comes from ATP, also from the photochemical reactions. Now let's look at the events leading up to photochemical reactions again after carbon fixation. So let's put things into perspective. This is the chloroplast. The thylakoid membranes are where photochemical reactions happen. And stroma is where carbon fixation happens, where carbon dioxide combines with H to form glucose. Now first of all, let's think about NADPH. The NADPH that was made in the thylakoid membrane during photochemical reactions will come out to the stroma. After they come out to the stroma, they will give up their H. The H will participate in carbon fixation. So for the NADP itself, it will go back, also by diffusion, to the thylakoid membranes. When it goes back to the thylakoid membranes, it will pick up more H from photolysis to form NADPH again. This NADPH will then go back to the stroma for providing more H for carbon fixation, and the cycle goes on and on. The case is similar for ATP. ATP was made during the photochemical reactions where a lot of energy from light was trapped in ATP. Now, in order for ATP to release this energy, it has to be broken down into ADP as well as P. After it is broken down, energy from this molecule will be released, and this energy can be used for driving the process of carbon fixation. The ADP and P will then diffuse back to the thylakoid membranes, where it will trap even more energy from photochemical reactions to become ATP again. And this ATP will then diffuse back to the stroma to provide more energy for subsequent carbon fixations. The cycle then goes on and on.